Hello, everyone. This is Coach White, and welcome to the Cycle 5 Test 3 review. If you are not in my class, welcome. I'm just going to review a lot of things from your practice test, maybe your at-home review, a lot of questions that my class had. So I'm going to go over those, and if you're in my class, welcome. Here's the video I decided to make for you guys. The first thing to remember is during this test, okay, this is what we're going to be talking about. Our whole unit is on quadratics, also known as the parabola, okay? So our shapes are going to look like this, or like this, okay? These are quadratics and our parabolas that we're going to be working with. And remember, we know it's a quadratic by this 2 right here. So if we have a problem and it has some x squared, that means it's a quadratic, okay? So just a little reminder there. So here's the first one that we have. It says, what is the domain of the 9 minus x squared, okay? We know domain is dealing with x, and that is left to right. So we come over here. Beautiful. Let's pull out Desmos, okay? And pull out Desmos over here. And I'm going to put 9 minus x squared. Okay? So I need to go home. There it is. I am noticing with the domain that this quadratic, it looks like this, right? And it goes down forever to the left, and it goes down forever to the right. The domain of a quadratic always is going to be all real numbers, okay? So the domain of a quadratic is always all real numbers. That would be the answer to that one right there, okay? Don't let the other ones trip you up. This one right here. We talked about this one in my class a lot, okay? So it says a ball is placed in a machine that throws a ball up into the air, okay? So let's just visualize this. Here's our ground, and it's throwing the ball into the air, and we know with physics that the ball must come to the ground. Okay, so that's the path of this little ball right here. Let's just say it's like a basketball, okay? And it says the table represents some points on the graph of the function that models the ball's distance from the ground with respect to time since the ball has been thrown. What is the range? Okay, there are 2 ways you could do this. There is a table here. You could do regression in your calculator if you wanted to. Here's the other thing I'm going to show you. It's a little bit of a tip. You know when we have tables like this and x is on this side and y is on this side? Well, we know range has to deal with y, okay? So when you have a table, x is on the top, y is on the bottom. Since it is asking for range, I am only looking at these numbers. I couldn't care less about these. That would be my domain, but we are talking about the range, okay? So since we're talking about the range, I'm only looking at those numbers. So it's saying, okay, with the balls thrown into the air, it looks like it starts at 0, which is right here, which makes sense because a ball can't go negative, like the ground is 0. And it goes up and it goes up, and it looks like this is the highest point. Okay, so I have my 7.35 is my highest point, and then it's going to hit the ground again at 0. Okay, so looking at this, I'm looking at all the numbers here from 0 to 7.35. That is what I'm looking for. So I come over here and I'm like, this one says 1.25. That's not even in our picture that we drew. Not that one. Same here, has 1.25. That's not correct. Those are having to do with the domain. Now, please be careful. This is not correct. Okay? It says all real numbers less than or equal to 7.66. Okay, if this is all real numbers, I asked my class, what's a number less than 7.66? They're like, oh, Coach White, it's 4. I'm like, how about a lower one? 1. How about a lower one? 0. What's another number less than 7.6 that's lower than 0? Well, -2. On my graph over here, we just talked about this. We can't have any negative numbers because the ball can't go below the ground. Also, this is the lowest we have, and this is the highest. So that is telling me that my answer has to be this. Okay, because look, it's in between 0 and 7.6. Please do not let you trip it up. This is no. This one right here, people want you to get tripped up, but it's not this. This would be my answer. Sometimes drawing a picture helps, okay? You could also do regression if you want, but honestly, I kind of like just seeing that y is the range, okay? Ooh, I love this one. Okay, again, we are talking about which answer choice best represents the domain and range of the function. If you guys recall on our very first one, what did I say about this domain? The domain of a quadratic, let's write it. Okay, so domain of a quadratic is always all real numbers. It is always all real numbers. So let's look. This is a quadratic, right? Okay, this is a quadratic. The domain has to be all real numbers. Let's look. Okay, does that say all real numbers? No. Does this one? It looks like it, so this one looks promising. The domain, all real numbers? Nope. Domain, all real numbers? Nope. By process of elimination, this is my answer. Now let's triple check. Is y greater than or equal to 5? Let's look. Here's my lowest point. Yeah, it looks like, look, y is greater than or equal to 5. So this one is perfect, B. But as you see, just working just a little bit smarter, not harder, you know. We know that for the domain of a quadratic, it's always going to be all real numbers. So this one was easy. I could get rid of everything else, okay? This one right here, this one's fantastic because it has a lot of different vocabulary words that we need to talk about. It says the graph of a quadratic function k is shown on the grid. Okay, so it's just telling me this is my quadratic. It says which statement are best supported, okay? Remember this, best supported by the graph. Okay, this one's asking about an x-intercept. Let's look. Here's our x-intercept. Okay, what is this point right here? -3, 0. Oh, looks like that one's correct. Okay, let's look at the y-intercept. Let's look. You got to be very careful. Oop, looks like it's right here. What is that point right there? 0, 9. Looks good. Beautiful. Okay, axis of symmetry. Okay, remember that goes through the vertex. Okay, and since it's horizontal, remember our friend, we have our hoi bucks here. I mean, it's vertical, I'm sorry. So since it's vertical, it's going to be x equals, and it goes through -3. So x equals -3. Oop, looks like that one's correct. If they're all correct, man, looks like the answer is going to be J. Okay, the biggest things here is making sure x-intercept, y-intercept, axis of symmetry. Again, big reminder. X-intercept is the same as solution. It's the same as zeros. And it's also the same as, what's the other one? I can't remember off the top of my head. There's one more, but I can't remember what it is. So just remember x-intercepts, zeros, solutions, all of those. Okay, so let's make sure we remember those. Okay, this one right here says the graph of a quadratic function g is shown on the grid. The coordinates of the x-intercept, y-intercepts, and vertex are integers. Honestly, guys, this is just telling me that there's stuff on the graph. This is kind of like fluff. You don't need to worry about this. The biggest thing it's asking is the maximum, okay? The biggest thing that I tell my students, if there is a max, it is like you're climbing up a hill or Mount Everest. And here's my little guy. This is the max. That's the highest I can go. So max or highest. Then I'm going to go into the Grand Canyon, and here I am, and this is the lowest I can go, or this is also known as the minimum. So this is the lowest. Okay. So in this case, we have a maximum, and here's my little guy. He's standing at the very top right here. Okay. Let's move him down just a little bit. Okay, here's my little guy. He's standing at the very top, which is a max. Okay, if you were climbing a mountain, what is the highest this little guy is going right here? I know it's a little blurry. The highest that he is going is right here, 9. Okay, the vertex there, yes, this point right here is technically 9, what is that, 2? But since I'm talking about the max, just talk about the max height you're going. If you're going to climb Mount Everest, I'd say, okay, the max I climbed was 9 feet. Mount Everest is obviously a lot taller than that. But in this case, the maximum value of G is just 9. Okay, that's all we need. We just need the 9 because that's as high as our little friend climbed right there. But this I need you to remember, max and minimum. Okay. Ooh, this one's a little bit tough. We need to solve this by factoring, okay? On your test, you are going to have to do this by hand, so we need to make sure we know how to do it. Your teachers and I are going to be expecting work, show work, show work, show work, okay? The first thing we need to identify here is this is a quadratic, naturally, because that's what this whole unit is. If you have a quadratic, okay, so quadratic over here. Big note, set equal to 0. Okay, you have to set it equal to 0. This right here is not set equal to 0. So that means I need to start moving some things over so it is. So I'm going to go ahead and I'm going to add 13x to both sides. Okay, there's not a place to put it, so I'm just going to put it over here, 13x. Okay, and I need to add 3. Remember, combine like terms. Okay, let me go ahead and make sure our equal sign stays. Okay, so on this side, I have my 3x squared, my plus 13x, and then I have plus 4. These all cancel, so it's equal to 0. Bam, this is exactly what I want. Set equal to 0. You have to do this, okay? Say it in your head. Set equal to 0 if it's a quadratic. Set equal to 0, 0, 0, okay? Now we need to go ahead and factor this. So now my next step, so this was step 1, step 2, okay, step 3. Let's go ahead and let's do our x games. Remember, I'm going to put it off to the side. It's a times c, and then b is on the bottom, okay? My a is 3, my b is 13, and my c is 4. So my a times my c would be 3 times 4, which is 12, and my b is 13, okay? Just a small tip that I tell my students, if these numbers are super close, then these two are probably really far apart, okay? If you forget how to find the factors in the calculator, just put y equals 12 divided by x. Okay, this would be a calculator. You'd put that into the calculator. Okay, but I know that 1 times 12 is going to give me 12, and 1 plus 12 is going to give me 13. So these are the factors that I'm using right here. Okay, now big reminder, this is 4 right here. I'll do it in a different color so you can see it. This is 4. You keep the first, and you keep the last. Okay, now what I have highlighted over here is what's going to go here. I'm going to put plus 12x plus 1x. Okay, now what we are going to do, I'm going to make it really small and zoom in. This step right here is called factor by grouping. Okay, so that's the step that we are going to do next. Okay, so here I go, and I'm going to group these together. Bam, 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 bam. Okay. Now I know with this right here that I can divide both of these by 3x. Okay, it is the least common, or it's the greatest common between them. Okay. Another good rule of thumb is take out the lower one. This has a higher exponent, so take out the lower exponent. So this is what I'm factoring out. I have the 3x, and when I do 3x squared divided by 3x, I just get an x. And then 12x divided by 3x is just going to be 4. Okay. Now I know the other one has to be this. In my class, we say hashtag twins. Okay. These two have to be the same. And if they're not, then we did it incorrectly. Okay. So I'm going to come over here, and I know that between these two, there is nothing in common. So the only thing I can take out is a 1. Okay. So I'm going to pull the 1 out, plus 1. 1x divided by 1 is x. Good. Negative 4 divided by 1. Ooh, looks like we did something wrong here. Okay. So that means I need to check. Did I copy things down? Ooh, no, I didn't. Okay, I forgot to put the plus. Perfect. Now it looks good. You see how you can check your work here? Now for our answers, we're getting close. Okay, this is 5 now. Okay, I have the twins, x plus 4, and then I have 3x plus 1, and that's equal to 0. Okay, now we have to set these both equal to 0. I'm going to zoom in. This is going to be x plus 4 is equal to 0. Okay, so if I subtract 4 from both sides, this would be x equals negative 4. This one I'm going to do a little bit differently. I'm going to write the whole thing out. This is equal to 0. Subtract 1 from both sides, so I have 3x is equal to negative 1, and then I divide by 3. This would be x is equal to negative 1 over 3. Leave it as a fraction. These are my answers right here. Okay, this is the work that is expected. At least for me it is, and I know for your other teachers it is as well. This is the work that is expected for factoring. Okay, please make sure you show all the steps. Now here's the other thing I'm going to show you. Okay, let's look at step 2. I'm looking right here. If you want to check your work, okay, again, you can't use this as the main resource, but you can use it to check your work. If I come to Desmos, again, it's set equal to 0. So I'm going to put 3x squared plus 13x plus 4. Okay, here's my solutions right here. So that means I should have x-intercepts at negative 4 and negative 1/3. Bam, there's negative 4, and negative 0.333 is the same thing as negative 1/3. So you can use Desmos to check, but you need to have all your work. Okay, so what's boxed in is your answer, which would be this. Okay, that's a big one, so make sure you know how to do those. Okay, here's another one. Bingo! Look, this one's already set equal to 0. Okay, So we already did one by hand. So this one's going to be a huge number because if I did X games, it's going to be super big. So I'm going to come over here and it's set equal to 0, which is fantastic. There is a 0 here. Yay. Okay. So I'm going to come and put 3x squared minus 30x minus 72. And let's look. Looks like it says, okay, solution. Remember, this is x-intercept. Okay, so I have negative 2 and 12. Okay, so this one doesn't work. Negative 4, and this is trying to trip you up. It says negative 12, but that's incorrect. Okay, so it's not negative 12. So our answer here would be negative 2. Okay, not too terribly tough. Again, if you did X games here, y'all, this would be a huge number. Okay, so if it's set equal to 0, you can also use Desmos to check. Okay, this one right here. We are going from the solid black line to this line. Okay, so let's just put in words what's happening. Okay, so it looks like I'm going to the left 3. Okay, so I'm going to put left 3. And it looks like it reflects, right? It reflects downward like this, so it has reflection. Or ROXA, which stands for reflection over x-axis, okay? So this is the same thing. So I need to look for a problem that has a left 3 and a reflection. Well, reflection doesn't help us because they all have a reflection. Okay, we want to go left 3. This one right here, why is this one incorrect? Right, remember, inside is the crazy x. So this right here is actually telling me that it is going right 3. Incorrect. This one right here, oh look, plus 3. Remember, crazy x. This is going left 3. This one looks promising. This one right here, this means up 3. And this means down 3. So these don't work either. So it looks like my answer is going to be B. Okay? I like to do this first so it doesn't trip you up. Put all the transformations first. Okay. Here's another one. First question I'm going to ask. Is this a quadratic? Yes, Coach White, it's a quadratic. Yes, it is. Okay, if it's a quadratic, what can we do? Set equal to 0. Okay, so we need to set this equal to 0. So I'm going to do that down here. Okay, so I have 2x minus 7 squared equal to 32. If I want to move it to the other side, I got to subtract 32 from both sides. So now I have 2x minus 7 squared minus 32 is equal to 0. This goes into Desmos, my friends, okay, because it said equal to 0. So let's go ahead and let's do that. Okay, so we have 2x minus 7 squared minus 32. Okay, and it's asking for the solutions, which also means x-intercepts. So let's look. 3 and 11. Look, easy money. 3 and 11. Perfect. Okay. Now at one point you're gonna have to do this by hand, but I'll show you in a little bit. Okay.